Hey guys, so this video will capture some basics of using Kubernetes with the Google Cloud Platform. Now, Google Cloud Platform is is basically one of the alternatives to AWS and Azure and some of the other cloud providers out there. So this is an offering from Google, obviously. Now, what I'm using here is a free trial of Google Cloud, and basically, in order to, I guess, in order to get people into their platform, they have offered about $300 in credit, which you can use towards your commissioning your cloud instances and basically trying this out for a maximum of, I believe, 60 days. And this is a great way to try out Kubernetes with Google Cloud. So where does Kubernetes connect with Google Cloud? Kubernetes is the clustering technology that is basically driving most of the containers that are launched by Google while doing its work. And that means that it is basically it is being touted as production grade containerization technology. So, okay, having said that, what do we need to get started with Kubernetes and Google Cloud? Well, first of all, in order to interact with Google Cloud, we need the Google Cloud SDK. And here I'm on a Linux machine, so I'm going to download it. Once the download of this tar file completes on Linux, the next thing to do is to run the install script. Now I have already run this, but basically all this does is enable bash completion for your shell. So what I mean is that typing gcloud and then hitting enter should give you some output other than no such command. So Google Cloud comes with several core components and the option to install additional components. You can call them plugins. Now the way to list all the components is gcloud components list. And you can see that tab completion is working. This is because of the install.sh script that I ran previously. So this gives me a nice output of all the components that are available and that are installed. So now these are the components that are installed, etc. Now one of the components I want to draw your attention to is kubectl, which is basically a command line controller for our Kubernetes cluster. So let's just quickly install that. Gcloud components install component ID, as you can see here in this output. So component ID is kubectl. Yes. Okay, the installation has been done. Let's just quickly check. Yeah, okay. The installation is finished. So the other part of this puzzle is that you need a Google Cloud Console account, and Google Cloud for new users is giving out $300 in credit in a 60-day trial. And this is a good way to get started with Google Cloud and kind of try out all the different technologies and offerings that Google provides through this platform. So the cloud platform is basically a dashboard that allows you to monitor your Google Cloud project. It's similar to your AWS dashboard. Having said that, once you sign up for Google Cloud, I'm not going to go through all those procedures here because it's fairly straightforward. Once you sign up, you will also need to provide a billing method like a credit card or something, and you don't get charged for the first 60 days. Post that, I believe you can opt out of getting charged automatically. I think by default you do not get charged, so you don't have to worry there. So the cloud dashboard is basically the interface you will use to create a Google Cloud project. I have some example projects here. So this is basically how an example project looks. Now, you will create an all new project for your Kubernetes experimentation. And that project will basically encompass all your project specific settings. Now here I have an Android project. So this is an Android cloud based application. So I don't want to mess up my Android application settings with my Kubernetes project settings. So that is the funda of creating a separate project. So let's go ahead and create a new project. Choose a unique name for it. So now, as you can see, every time I choose a project ID is generated, and that is basically the name of my project followed by some unique set of numbers. And this project ID is important because our Kubernetes controllers and project scripts will reference this. So we need to note this down in a safe place. After clicking the create button, the project gets created. See, it's available. No, still creating it. Great. So here's my project dashboard. Now let's just note down this project ID here, 143005. And in our terminal here, let's create a variable called project ID, Kubernetes app 143005. What's next? So the way that Google Cloud interacts with Kubernetes is by using the Google Container Engine API. I'm not going to go into the details of this, but what that means is that we need to actually explicitly enable this API in our Cloud Platform dashboard. So in my dashboard, I need to click this sidebar, I need to go to API Manager. So the idea is that it's a kind of a security thing that Google does not enable all APIs by default. There are over 100 plus APIs available with Google Cloud. All these are the APIs that are enabled in my account. As you can see, the Container Engine API is not enabled. The idea is that you can enable the APIs that you're using. So some attacker cannot use the APIs that you're not using and use them to exploit your account. So in the dashboard, click the Enable API and search for Container Engine. Here it is. So this is the API that is used for building Docker-based container applications with Kubernetes. Okay, so let's hit the Enable button. More documentation on this is available. In the enabling page, you will see links for documentation. There is a very cool little tool called APIs Explorer if you want to explore the API itself. But in production, it is not likely that you will need to know the ins and outs of this API. So quick summary, we have so far set up a Google Cloud account. We have set up a Google Cloud project that will manage our Kubernetes application. We have installed the Google Cloud SDK and kubectl component. Now it's also a helpful idea to do gcloud init. Now this basically initializes our Google Cloud console with several stuff. For example, now it's asking me for credentials. Hit yes. So this basically uses OAuth to authenticate me with Google accounts, and that's my Google ID. And now it is going to ask me which project I'm going to use. I've already chosen this project as project ID, but let me just choose it anyway. Number 2, which is basically this guy. Do I want to configure it? Let me choose yes. I can choose a region where my compute engine will launch containers. So we choose East 1A. 1. All right, great. So Google Cloud SDK has been configured with my authentication account, with my specific project, with a region and a zone. And this output will also spit out some additional commands that you can try later. Okay, so now that a lot of our initial setup has been done, the next step is to have an application, because ultimately all this is about running replicated applications in the cloud. And here is my awesome application. This is basically a web server that runs on Node.js. And I don't know much Node, but what I do understand is that this is launching an HTTP server listening on port 8080. I also know that this is the response that will be generated with a header of 200. Okay, so now let me launch this web server, node server.js, and let me launch localhost 8080 hello world. There you go. So that's my awesome web application. Now, since we are talking about running containerized applications on the Google Cloud, obviously we need an image, a Docker image. So this is a very simple, dumb little Docker file that all it does is it uses Node as the base image. So this is the official Node Docker image from Docker Hub. I'm using a specific version of Node, and then I'm exposing port 8080, obviously, because my application runs listens on this port. Then I'm copying my previously created server.js, this file. I'm copying this file over to the present working directory inside the image. And then whenever the container starts, the command that runs will be node server.js. It's a very simple Docker file. Obviously, these are all placeholders, and in a real application, you would likely have a Docker Compose or some more complicated way of launching real world applications. Now I need to build a Docker image from my Docker file. The other thing after I build my image is that I need to push it to a Docker container registry. Okay. What that means is that now this image is my basis for launching my containerized applications. And what Kubernetes assumes, Kubernetes as well as Google Container Engine assumes, is that your image, the image that contains your application, is present in a public or basically in a repository that is available to Google Container Engine. So in order to do that, now in my case, I am simply using Docker Hub, and in order to push it to Docker Hub, I need to tag it in a certain way using my Docker Hub ID, and then / and then the name of my image, and then a colon, and then v1, which basically represents the version of this image. And this is all basic Docker stuff. The mechanics of tagging an image are well documented. Once you tag it in this way, now in this output below, it is basically building the image. Once it builds it, you would need to push it. This is basically a process of uploading it to the Docker Hub. Now that the image has been created successfully, let me just quickly list my images. In my image list, you can see my image. So now I'm going to Docker push it. Docker push. Now it is pushing to my Docker Hub. In production, you would not need to do this in a manual way every single time. The idea here is that the process of pushing to your whatever is your repository, that process is likely to be automated. So there is all sorts of mechanisms such as a Jenkins job which can listen to your repository of code and build a Docker image and push that to your Docker repository, whether it be Docker Hub or whether you're using Docker trusted registry, or wherever it is. All right, so our Docker image has been pushed. And if you were to go to your Docker Hub account, here I have logged in already, then you can list out all your publicly available images. Now obviously I'm using the free account, so my images are all compulsorily public. I'm allowed to have one private image in Docker Hub under the free tier. So here's my Docker image that I just pushed. Let me look at the tags. So I pushed the tag v1 about a couple of minutes ago. On a side note, the Docker Hub is not the only way to store your images. Google Cloud also provides you what's called a Google Container Registry. There's a fancy way of saying that it's a Docker image registry. And the command here is gcloud docker push. Let's just quickly do gcloud docker. Right. So gcloud docker essentially runs Docker on gcloud, and there is a push subcommand for it which pushes the image to the Google Container Registry. Now it's obvious that if you're going to be pushing to the Google Container Registry, then you need to have a separate tag. By default, when you do a simple Docker push, it appends or prepends docker.io to the beginning. But if you're going to be pushing to GCR or Google Container Registry, you need to prepend gcr.io. Just a quick note. We are going to be proceeding with Docker Hub in this example. Okay, now that all our initial setup has been done, the next step is to actually create the cluster. And this cluster is going to be created in Google Cloud, and we are going to be using the Google Cloud SDK. And the command we are going to be using, the subcommand, is called container. So that is gcloud container. Okay, now there is a subcommand under that called clusters. So we will be running gcloud container clusters. All right, and there is another subcommand inside that called create. Right, the command would be gcloud container clusters. I believe that's what it was. Yeah, and then create, and let's call it kube cluster. Now this will take a bit of time. It takes about 3 to 5 minutes on average, and then it gets created. So here's your information on the cluster. Just as a double confirmation, you can go to your Google Cloud Platform. Here's your project dashboard, and as you can see now, it's a lot more colorful. There is some CPU usage being reported. There is some API usage being reported. All this is because the kubectl and your Google Cloud SDKs were working. Now to actually take a look at your cluster, you need to go to the sidebar, then click Container Engine, and here's your cluster. The tick mark means that it is running. Let's click on this, and here you go. Here's your endpoint. Here's your total size. This is just default, so you can always configure this. The cluster size is 3, and then your CIDR range and other parameters here. Oh, and if we were to use the Google Container Registry to store our images, then it would be available here. Of course, we are not. We are using Docker Hub. Once our cluster has been created by name kube cluster, we are going to run our image as an application on this cluster. So now for that we are going to use kubectl. So the command is kubectl run kube cluster, that is, this is our cluster name, and then here's our image name and the tag, the name of the image, and then the version. And since this application requires port 8080, we are also listing a port to expose. And if all goes well, you will see this success message. Let's go over some of the basic commands that kubectl offers. Kubectl get deployments. I think it's deployments. Okay, here's our deployment. And then to get pods, a pod is basically a group of containers. Like in our example, we're using Docker containers. So a pod is a group of containers, and all the configuration for that container, such as shared storage and all that kind of stuff. And the last command that we will run here is cluster info. Some nice little metadata about our cluster itself. Okay, so supposedly we have created a cluster, we have uploaded an image, and we have run a pod on this cluster in the form of a deployment. But all of this does not work unless we can access it from the outside. So the command to do that is kubectl expose deployment, and then the name of our cluster, and then the type of expose, which is load balancer. So one of the cool things about Kubernetes here is that all the concepts required to run a production grade application, such as load balancing and all, are kind of inbuilt, and they are all possible through single commands, and the integration between Kubernetes and Google Cloud is quite good actually. And what we have done here is that we have exposed the deployment and not the actual containers. So the logic of which of our containers, so keep in mind that this is a cluster, right? So our containers are running in a load balanced kind of a setup. So instead of exposing the containers themselves, we are exposing the deployment to the outside world, and the logic of where to redirect is handled by the load balancer. Now to access this deployment from the outside world, we need to get the public IP address. So that is using the command kubectl get services kube cluster, which will output for me the load balancer IP. Here you go. And if I were to feed that IP followed by port 8080 into my browser window, I would be able to see hello world there. So through this entire flow, what we have done is we have deployed a sample application running on Node in a container form into a Google Cloud cluster, and then we have also set up a load balancer for it, and then we have accessed the exposed IP address and access this load balanced, clusterized, containerized application. Obviously, one of the biggest advantages of clusterized applications is their ability to scale based on demand. Now, suppose I have a sudden need to scale this deployment, then that is again possible using this declarative kind of approach, using the command kubectl scale deployment. Okay, and I specify the replicas equals, let's say, 4. Of course, I have to specify the name of the deployment. All right, kubectl get deployment. So the advantage of the kubectl approach is its kind of declarative command style, in that you are basically telling Google what you want. You want to scale the application to 4 deployments, and then what it does is it essentially scales up the application over time. You can see that I ran this command 3 times, and over the course of 1 minute, it automatically reconciled what was desired with what was available. I can also take a look at the pods available using the kubectl get pods command, and there you can see several pods are running. And here is a quick architecture of our deployment. Here's my development machine, and I'm interacting with the cloud using kubectl. Here's my load balancer block, right? And this guy is choosing which of the nodes it should access. And I have scaled my deployment to 4 replicas. So there are 4 pods, 1, 2, 3, and 4, each running my application. And the load balancer automatically chooses the correct node to serve the application out to. And here are the clients that are accessing the load balancer.